Okay, so Infinera, I think you have, as a company, have identified some trends to do with data centers and connectivity for the year ahead, and it'd be good perhaps to go through those and give us a bit of detail about each. So the first one to start with, I've got a list here because they're quite long, so I can't necessarily remember them all in my head. So excuse me for reading, but I think the first one is to do with the need to meet the economic and capacity challenges of evolving data center connectivity trends with high performance optics. So perhaps you can just expand on that as a trend.
Yeah, so I guess there's two aspects to high performance or data center optics. One is inside a data center, and one is optics for connecting data centers. So if we focus on optics for connecting data centers, we obviously went through quite a boom with 400G pluggables, known as 400ZR, which kind of came out a few years ago. And really this year and next year, we're looking into the next generation of that, which is the 800G product. This is where, the performance of maybe traditional optical transport systems is really being condensed down into a pluggable form factor, and is allowing us to just continue to transfer massive amounts of capacity between data centers, so DCI networks at 800G per port. And really these 800G plugs are going with the new 800G router interfaces, which are also being brought into DCI in the next year or two. So there's a real step change in kind of coherent pluggable optics happening, end of this year, but a big ramp at the end of next year. On inside the data center, we're seeing a push or obviously an explosion in 800G interfaces, largely driven, as you mentioned, maybe by an AI boom around data centers. And the absolute volume of 800G interfaces is enormous. As we go from 800G to 1.6T, which is the next generation, really there's a real strong emphasis on power consumption. And maybe this is a question that you'll have as a follow-up in terms of like total energy consumption of these data centers and how they scale as a function of time, as a function of capacity. So really what we see outside the data center is pushing to the next gen of 800G, and inside the data center is a real focus on energy efficiency, and of course cost has always been a key metric inside the walls of a data center.
Yeah, so I think the next trend, which is, as you suggest, I think related, is the trend to maximize the data center interconnect networks with high speed, low latency, and power efficient optical engines. So yeah, perhaps you can just say a little bit more about that.
Yeah, so typically the best way to get more efficient at sending transport is just by sending a higher and higher speed or higher data rate per interface. Typically, the power consumption doesn't scale too badly as you increase the data rate, so you can normally get a factor of two or approximately in terms of number of bits you can send for the same amount of power within reason. So as we go from 400G to 800G, we're really trying to minimize the power consumption of those devices, and this is being achieved by using the latest silicon nodes from the big silicon foundries, and more optimization around the whole coherent engine to really minimize that power consumption but maximize the performance. So there's a huge emphasis on that. I think in the last couple of years there's been an enormous amount of innovation to try and morph technologies that are more common in long haul networks, but port them into the pluggables such that we really maximize that capacity for DCI. And that's something that we've seen through the standardization bodies over the last 18 months, and something we're going to see in production, at the end or beginning of next year.
Okay, and in terms of, I suppose, the what we might call the consequences of some of what we talked about, I believe you're also saying there's going to be a focus on cost per bit and power per bit calculations in terms of these data center interconnect network, the transformation that's going on, and I guess with the idea being clearly to outline or understand what the benefits should be.
Yeah, what could you repeat the question? What the benefit is in terms of?
Yeah, so I mean, I'm thinking the benefits in terms of things like reduced capital expenditure, lower space and power consumption, simplification, stuff like that. So that just thoughts around that.
Absolutely, absolutely. And the coherent pluggables really bring all of that. In conventional systems, even for DCI, maybe going back a number of years, was you have some kind of router, you have a gray optic interface which talks to a transport box. The transport box then sends the information to the other data center, and you have the reverse process on that side. Now, with the evolution in our technology, we're able to get all of this transport box type of functionality into the pluggable itself. So you put the pluggable directly in the router. So now you have just this dramatic step improvement in power efficiency, cost, and density. And it's not just the interface itself. It's once you remove these boxes, you also remove things like fans, which consume as much or even more power than the coherent or the optical interface themselves. So really, by being able to put all this technology into a little pluggable, you just get this dramatic step function improvement in capital expenditure, operational expenditure, size, density, and of course energy. And all of those things are hugely important for data DCI, and will continue to become even more important as data rates continue to explode.
And in terms of architecture and management considerations, I'm thinking things like IP over DWDM and the intelligent coherent pluggables that they're becoming mainstream. So just thoughts as to what they require in terms of the architecture and management considerations, I guess, within the data center.
Yeah, and you have quite a mix in terms of how end customers want to manage these pluggables. So in one side, you can do IP over DWDM, you put the pluggable directly in the router, and you can control the router, the pluggable through the router interface or through the router operating system, and set very simple parameters. There's other parts of the network or other parts of the industry where you want to have a much richer set of control around the pluggable and have options for things like telemetry and to help you figure out what's going on in your network. And you want to be able to connect the pluggable directly to your SDN controller or your optical layer transport controller. So in that part of the network, which is very relevant with content service providers and cable providers, you need to have a pluggable that can be operated in both schemes, both communicated via a router, but also communicated directly from an optical transport layer controller or an SDN controller. And that's hugely important, because if you go and poll the industry, what's important about coherent pluggables, or what's one of the biggest challenges about deploying them in a network, you'll see the biggest response that comes back is manageability. The operational aspects of deploying pluggables instead of conventional transport equipment. So that's something, at least at Infinera, which we're really trying to drive forward and in fact try and pioneer kind of this intelligence within a pluggable. So it's not just a kind of a dumb device that you stick into a router.
And in terms of I started out in the IT industry in storage, so heterogeneous storage was a massive thing, and it never it was always there and thereabouts, never quite right. And I think one of the trends you identified, there's a need, or users want multi-vendor transport networks in order to get those really working properly. I guess I think you're suggesting there's a need to evolve industry standards and multi-source agreements. So I suppose, where are we now? How easy is it right now to put together multi-vendor solutions, and what's missing to make it even easier, or to actually make it practical to start with?
Yeah, I think there's some good collaboration within the community. I think today there's probably too many MSAs and implementation agreements out there. In the 400G and the 800G devices, we have stuff being standardized in Open ROADM. We have stuff being standardized in OpenZR Plus, in the OIF, in the ITU, and there's aspects in the IEEE. So it's a bit dispersed. And I think there is a real drive and effort to try and get that more focused, because typically, companies or vendors like Infinera are making a single pluggable that's going to solve all these problems. And it gets a bit dispersed and a bit more challenging to try and make sure you cover all aspects of technology in that fashion. So if you look at, say, the coherent part of it at 1.6T, we just had a project start in the OIF for 1.6T ZR, which is the next gen to 800 ZR. But we also had another project start for 1.6T ZR Plus, which is meant to capture the more differentiated features around, or higher performance features of coherent pluggables, which kind of allow them to do DCI, but over kind of a metro or a long haul network. So DCI networks where the data centers are very far apart. So that's a big effort to try and consolidate some of these efforts, at least into one forum, which right now is the OIF, and to try and kind of get that, standardization of that MSA being held within one entity. I think that's a positive for the industry.
And in terms of, I think you referenced earlier, but the world and his wife is talking about AI and the impact it's going to have. Yeah, it's in the headlines everywhere, is it? Technology and on the news. But in terms of the sort of requirement from a network connectivity point of view, I mean, are we imagining there's going to be formidable design and deployment challenges to respond to the AI explosion, or is the technology already there? Just thoughts on
that. Well, the technology is and it isn't, I would say. People are making improvements in technology, but really with the explosion of AI, you're really looking and have a really sharp focus on energy consumption. And of course, cost is always underlying, so that's a given. But energy consumption is something that's becoming so challenging. And typically with a lot of data centers that are already out there, municipalities can't just continue to increase the amount of power going to a data center. But as a data center goes from supporting, let's say, 400G interfaces to 1.6T interfaces, they can't just quadruple the amount of power consumption. That just cannot happen. So there's a lot of disruption in that space. And there's a lot of, I think, opportunity for disruption to get step function changes in energy consumption. And that's something that maybe at Infinera we're kind of focused on as well. What kind of differentiated value can you bring there to continue to scale capacity at the rate that it's going, but at a sublinear scaling of power consumption? That is absolutely critical. And I think if we don't have kind of laser focus on energy, it's going to be very, very difficult to continue to scale capacity at the current rate that it is.
Okay, and what other trend? I mean, edge data centers have been talked about for a wee while and perhaps haven't progressed as quickly as possible. But there's also, I think, an increasing trend for megascale. I'm hearing, there are some huge, great megascale data centers being built around the globe. So if it's a silly question, apologies, but are either the megascales and or the edge ones putting any particular strain on connectivity, or again, is the technology already there to optimize both those environments, or do things need to be done to help as and when these become major trends?
Yeah, obviously the scale of data being transferred in and around is kind of different between maybe a mega data center and something like an edge data center, where you're kind of generating, consuming a lot of data at the edge. We would like to do a lot of your AI operations at the edge. Although maybe you can't train big AI engines at the edge, you want to be able to run train models there. So it's dependent on what kind of transfer flows you have going from the edge back to the main data center. And I think like anywhere else in the network, there's a continuing push to drive energy down. And I think something that we personally have worked on for a number of years is this concept of coherent point to multipoint, where we have people who are looking to put a mini data center at every radio tower, for example, completely distributed around the network. That mini data center doesn't need the same amount of capacity or connectivity as a hyper data center somewhere else in the network. So part of our solution set that we look at to service that part of the network is to have a coherent optical interface which can go into a router, which can broadcast a signal to multiple different mini data centers at the same time. And the reason why we try and do this is to remove real estate, to remove boxes out of network, with the ultimate aim to reduce capex and opex. That's the name of the game, right? If you want to bring coherent to the edge, or even coherent into your home, it has to be cost effective, and the status quo doesn't quite get you there. So really, whatever part of the network you're looking in, we're looking for differentiation that's going to give us some kind of step function change in power and energy, power, and cost. And typically, the best way to do that is to take elements out of the network and replace them with more efficient solutions. So at the edge of the network, we're kind of pushing hard with coherent point to multipoint. At DCI, we're really pushing on coherent high performance coherent pluggables for point to point.
Yeah, maybe just to finish up, as I say, I mean, storage was my background, but clearly working in data centers, get to see it all. And I'm just wondering, there's always a bottleneck somewhere. Sometimes it was the storage, sometimes it was the compute, sometimes the network. I mean, in terms of that now, where does the balance lie? I suppose, who's lagging behind, who's leading, or is everyone in sync at the moment in terms of the feeds and speeds, or who needs to pull their socks up, if you like?
Yeah, I guess the whole data center industry isn't going together in unison. Some are a little bit faster than others, and maybe that's always going to be the case. I think, in a data center, you want to spend all your power on compute, right? That's the function of having the data center there. You want to spend every bit of power you have on compute, and you don't want to spend power on networking infrastructure, right? Networking infrastructure is just there to facilitate the compute. And I think as the speeds continue to go up, you're seeing a disproportionate amount of energy going on networking instead of compute. And I think that's where, we need to pull our socks up and say, how do we ensure that the power consumption is being spent where we want it to be spent? And how do we minimize the networking piece? And I think that's, you're asking maybe how things are changing, and is the technology already there? I think it isn't right now. I think as we keep going the way we're going, just the amount of energy on the networking piece is disproportionate versus compute. So I think that's where we need a step change. I think that's where a lot of the industry are working on right now, and really looking at that with a really close view.
And on that point, is it something, does everybody understand, if you like, the steps that are required to improve that power performance ratio, or is everyone sort of at the moment searching for the magic bullet to get there, or they know what they've got to do? It's just a question of getting there over a period of time.
Yeah, I think so. There's maybe some magic bullets out there, but nothing comes easy. So people are looking at things like linear drive pluggables or co-packaged optics, right? Where you have a step change by removing, in the terms of co-packaged optics, you remove the pluggables from the router altogether. That gives you a step change potentially in power consumption, but it also brings with it an operational headache. It maybe brings you a vendor lock-in. It brings you interoperability challenges and things like that. So there's probably a vision to get there, and it will happen over time, but there's a lot of challenges to work through between now and then. And most of the challenges actually maybe aren't technical. They're more from an operational standpoint. And that's before you even start talking about, liquid cooling and other types of things like that, which will also be maybe a step change in power consumption for data centers in the future.
Yeah, and also, I mean, just apropos of nothing, but I mean, photonics as well, I guess, is got an opportunity to make a big difference in the data center, which it perhaps is in the early stages doing. Is that fair to say?
Yeah, absolutely. I think, like I said, just continuing to reduce the power consumption of the optics, so the networking component stays within a small proportion of the overall data center power consumption. I think that's the goal, and I think people have a clear view of where they want to get to. It's just going to take time to get there.
Okay, it's been fascinating to chat to you, and some great insights. So, Robert, really enjoyed it, and thanks for your time. Thank you.
Okay, thank you very much.